Hello interwebs, welcome to Let's Fix Computers. I've got a pair of big old iMac G4s in front of me. So these are vintage Macs, and these were brought in by a client who wants me to build a working one from the pair that we have before us. And I've already told him that these things are just, they're obsolete, they're vintage, and they're too common to be worth anything. They're in that weird Apple state of these things are kind of weird and kind of interesting, but they're not really good for anything, which is the state of a lot of old Macs at the moment. It seems like a pity to throw them out, but it's a G4. What are you going to do with it? You know. However, he was just like, yes, I understand. I will still pay you to make of them what you can. And I'm like, okay then. So yeah, we've got two of them. They're both slightly different ages, and they're both in a various state of missing parts. So firstly, we've got to identify what we've got. Now, I believe that one of these is a dual CPU, and the other one isn't. So the first thing I'm going to do is plumb the serial numbers into a serial number lookup tool and find out what their original spec was supposed to be, so we know which chassis we should work from. So what I'm going to do for this, let's just take a wander over to my desktop. And I'm going to bash into Google Ultimate Mac Lookup, which will come up with this everymac.com website. Really handy utility for identifying Macs. So, the serial number I've got, this is a CK250MXD. Okay, I am not a robot. Okay, right, let's see. So, it's a Power Macintosh G4 DPMDD, so mirrored drive doors. That is what I recognise them as. The mirrored drive doors, that is referring to the mirror on the front of it. As opposed to an even older one I've got at the back that doesn't have the mirrored drive doors. So this was one of the later ones, I think. What's the day on this? Yeah, it's 2002. All the way up to January 2003. Blimey. Well, yeah, I guess that is when the G5 came out. Sometimes I'm surprised by how long. I just always assume these things are from the late 90s for some reason or other. But yeah, okay. So it's a 1.25 gigahertz G4X2. So this one apparently is a dual CPU one. And this is the older one of the pair that I've got. And the reason why I know that is that the other one has a new style font on the back. So I think the other one is actually a newer one. But interestingly, well, of course, newer doesn't necessarily mean better. So yeah, okay, that's fine. So that is potentially our dual CPU one. Let's see what the other one is. Okay, so this one is like 1 year newer. It's 2003, discontinued 2004. So it had, however, it is lower specs across the board. It's a 1.25, but single. It's not a ×2 there. It's got a newer combo drive in it. However, it had a smaller hard drive and less RAM. What's the VRAM 64 meg? The other one was 64 meg as well. So yeah, basically the other one is a slightly newer chassis, but the actual spec of it at the factory was older. So that's kind of interesting. Do they have matching ports on the back? The ports on the back do indeed match. So theoretically, we could move. I wonder if we can move the CPU to the newer chassis, just simply because that's going to have a newer power supply and stuff like that in it. Or maybe I'm overthinking this. I don't know. Well, we know what's got what in it. Let's open them up and see what's missing from the two so we can find out what parts we need. Because I think we're going to have some missing parts. So let's skip over to the bench. Okay, so here's the newer one. Let's open her up. Ba-ba! Okay, this one looks pretty threadbare inside. There's no drives in this. It's still got its optical drive. The combo drive is present. Power supply is there. DC output. 360 watts on the power supply. That's the modem, I think. Yeah, the modem is missing from this one. Battery is present. No RAM. CPU is all under this stuff. Not sure how difficult that is to get out. I don't think I've ever actually removed one of those before. I don't have a huge amount of time in the G4. I've changed power supplies in them and stuff like that, but not very often. However, the condition looks okay. Alright, so this guy needs RAM, a graphics card, and a modem. Well, we don't have to put a modem in, obviously. We don't care about the dial-up modem. I'm just thinking about completeness, you know. But that's looking okay. What about the other one? Okay, this one's got a lot more in it. The modem is present, the graphics card is present. We have a stick of RAM. Again, no... Oh, there's a hard drive in that one. Oh, the hard drive's right at the back. Am I blind? Did I miss the... Hang on a sec. I just need to check if I missed the hard drive in the first one. No, I didn't. Okay, so... Again, just a reminder, this was the... Yeah, so this is the older but higher spec one, and it's mostly complete. So really, the question is, and it's got a 400 watt power supply in it. So despite being an older computer, this one's actually better in every way, and it's more complete. And looking at the fan there has got less dust on it. This looks like it's had fewer hours as well. So yeah. There doesn't seem to be a lot I really need to do with this. To be honest, I'm not going to move any hardware. Well, for a minute, I'm considering chucking out this video because there's nothing that I actually want to move between them, which means there's not a lot of building that we're going to do here. But what we are going to do, though, is I do want to put some fresh thermal paste in it because rumour has it these things can be super noisy. So I'm going to change the thermal paste. And how much RAM is in this thing? $256. Okay, this thing is missing. This thing needs more RAM in it. It's DDR1. I got DDR1. Got some random CPUs in here. What the hell is that? It's a Core i5 2500. I wonder where that went. I was looking for that recently. But no, I don't have any DDR1. That makes me sad. I must have chucked it all out. Bummer. Well, DDR1 won't be difficult to track down, so that's not a big deal. I think we're going to take the CPU cooler off and put some fresh thermal paste on that. And I think what we're going to do is just do a little bit of a look around. We'll keep the camera rolling and see if anything interesting happens. God, that is a big heavy heatsink. And there we go, there's our dual G4s. That heatsink is heavier than it looks. Let's take that CPU board out. Okay, so to remove these, we literally just pull up from this end. Oh, God, that came out a bit suddenly. Wasn't expecting that. God, look at that. It's just that holding it on. Cool, let's take a close-up look at this while we change that thermal paste out. So here's our CPU board. I've done a quick cleanup on the two chips there, so you can see the cores exposed there. No multi-core stuff going on here, just two CPUs on a board. So these are quite kind of interesting. They've got an onboard level 1 and level 2 cache, which was 64K level 1, 256 level 2. And then they each have 2 megabytes of external level 3 cache. So we actually have external cache chips here. Whereas, of course, obviously on all your modern CPUs, your level 3 cache is built in. However, on older CPUs, I think the only notable CPUs to do this would have been, in this case, these G4s, but also the Pentium 2, I believe, ran external level 3 cache because it was also mounted on an external sort of daughter board as well. So you can see we've got 2 chips there, and we've got another 2 on the back. So these are going to be 1 megabyte cache chips. So those are going to be some fairly seriously high bandwidth memory that are directly on board, and they've got those mounted right up close to the chips, because obviously you want your caches to be as close as humanly possible to the CPU to reduce lag as the CPU talks to its caches. So there's not a huge amount more to see here. On the back of it, this is mostly just bulk decoupling, so all filter caps. If we look over here, we've got the power management chip for CPU vCore, bulk decoupling on the back here, low side MOSFETs, and on the top here we've got 2 high side MOSFETs. It looks like we're running 2 vCore phases here. So we've got 2 high side MOSFETs per phase, low sides on the back. We've got some I think these are the input MOSFETs, so there's a little bit of switching going on for the input. And then if we look on the back, they then go through these 2 big chunky coils, and then those inductors on the inside are then common together onto these 2 tracks here and here, which create the VCC main and the ground track. And then those are stitched into the center of the PCB, and will go off to they'll go onto the center layers of the PCB to power the chips in the middle. So obviously this whole lot, all of the CPU phases there, those are getting their power from this 300 pin chip. Just smushed some old thermal paste into that there. So they'll be getting their power from a chunk of these pins. I don't know the pin out, but there'll be a whole chunk of those pins that will be power input. A whole chunk of them will be ground, and probably surprisingly few of them will actually be data pins. It's often surprising how much of a large pin grid array like this, this is a LAN grid array. It will be surprising how many of those are just power related, because when you're pumping, like, these are probably 60 watts, I don't know, 40 or 60 watt TDPs. When you're pumping that kind of power through small lanes like this, you've got a lot of amperage there, because you're only running at like probably 1.5 volts, maybe 1.7 volts or something like that on old chips like this. On modern chips, obviously, you're running like 1 volt. And if you've got like a modern top end i7 is, 90 watt, 100 watt TDP at 1 volt, that's a lot of amps. That's like 100 amps. It's enormous. And so the only way to carry that kind of amperage is having lots and lots of pins. So a large amount of that is all going to be power. So yeah, that's about it. There's not a lot else on this board. It's literally just a dedicated board to stick those on. And the main reason why they did this is because this meant that they could do just BGA chips. They didn't have to put a chip socket in. And it meant that on the lower end models, they could just put a smaller board onto the same motherboard, which meant that they could do large changes to the CPU configuration of this computer. Because obviously switching from a single CPU to a dual CPU system is a big change. And on any normal workstation, that would require 2 different motherboards, perhaps. Although a lot of motherboards, you can have an empty socket. But, in this instance, this meant that they only had to put in the dual CPU power system and all the rest of it just onto this board. And on the lesser computers, they could put in the cheap board. So interestingly, we may as well take the other one apart and take a look at the CPU board for there, and we can compare them and see how cut down the single CPU board is by comparison. That'd be kind of interesting. In the meantime, I'm going to put this back in the computer, and we'll get the CPU cooler fitted onto it again. So the rest of this motherboard, it actually looks fairly threadbare for a motherboard. But the reason for that is that it's probably fairly double-sided. I was about to say I'm not going to take this board out, but since we're basically doing a walk around of this thing, it would be rude not to. I'm curious as to have a look now. So I'm just going to remove that guy. That's a spring clip mechanism for the CPU board. But what we can see on this side, firstly, the bit that we're missing here is where's the main chipset, because it's not going to be this fella. This is a Southbridge chipset. It's too far away from the action to be the main chipset, and it's too small. So this is our Southbridge. We've also got This guy up here is just some SRAM for, it's basically the, I can't remember what it was called on these ones. I mean, they say they've got a PMU reset there, but that's like power management unit or something like that. But it was the NVRAM, that was it. It's the NVRAM, non-volatile RAM. So that was essentially your BIOS settings, and this battery is just keeping that fella powered. We got some Pci-X slots here, not to be confused with PCI Express. It was a slightly fancier version of PCI that had extra bandwidth for fancy stuff, big SCSI cards, that kind of thing. Don't know a huge amount about it because it was a bit of a niche connector that was only really seen on workstation class stuff. We've got an AGP slot here, which is probably 4 times. And it does have some interesting things because that AGP slot there, if we take out the graphics card, it's got an extra connector on it, which I haven't noticed before. Because as I say, I haven't really looked much at G4s. But if I take this graphics card out, we've got this extra slot down here, which goes into there. And I'm guessing, oh, I know what that is. Oh, that's fun. I was close. I was going to say it's power for the graphics card. But I'm wrong. It's not power for the graphics card. It's power for the monitor. So this graphics card has got the ADP, Apple DisplayPort. So this is it's a DVI connector, but as you can see, it's got rounded edges. And the deal with this thing is that this carries 24 volt power, and you can hook up an Apple CRT monitor to this, and it will deliver power over this connector. Power for a CRT, big chunky monitor. It was like sort of, the first time I saw it, I'm like, you're joking, you can't power a monitor from your graphics card. You can. It was a great idea, and I don't know why more people didn't do it. But I don't know. At any rate, yeah, that's what it did. And so this slot connector here, you can see by the traces that are going straight up to the ADP connector on this graphics card, that is our big 24 volt connection going that is powering the ADP connector. That's all it does. And so this here, for this Mac Edition graphics card, it's not powering anything other than that connector. The GPU itself is getting all of its power from the AGP card. So speaking of GPUs, this has got a silicon image chip on it, so I don't think it's anything fancy. It might be an ATI. I think it might be an ATI. These things were specced with ATI Radeons in them. Oh, by the way, sorry, 28 volts. 28 volts, 4 amps. What's the maths on that? Cool. That's 112 watts. 112 watts you can pump out of that. That's blinding. Oof, however, it's gone bang. Take a look at this. Get a load of this. The magic smoke has escaped from that. So that looks like it used to be a decoupling capacitor. However, that has gone bang in all ways it's possible to go bang. What's that powering? What's on the other side of it? Goes up to there. I'm not sure if that's critical or not. It's not directly on that big old card edge connector there. Either way, though, is that shorted to ground? Because this is going to be relevant for when I try and power this thing on. I don't actually know if these things work or not, you see. But if that graphics card is Gonski, then that's real bad news for this project. That'll be ground. So we should have ground on the back. Yeah, what about ground on that side? Whoops. Well, that guy's shorted to ground. We could take that off the card. I can't power it on like that because there's a risk that guy might just go up in flames. So we're going to have to remove that from the card, and then we'll see if the card is still intact. It's probably why this thing isn't in use, because the thought had occurred to me as I was opening this thing up. I was like, it's missing a RAM stick, but this thing is complete. What's the deal? Why is it being delivered to me as a non-runner when there's nothing missing from it? That's why the graphics card's gone ski. So yeah, rip that card. Let's see. We'll see if we can bring it back just by removing that dead cap and just see if that's enough. Okay, I was removing the motherboard from this. Okay, sure. Let's take the motherboard out so we can look at the other side of it and see what that chipset looks like. Doesn't look like there's a huge amount involved in that, and I'm kind of curious. So I've got to take this guy out. This is the modem connector, because that's technically an optional extra. They didn't build these into the motherboards. Don't know why, because it was more or less a standard feature. Maybe they just didn't have space, or they just wanted to... It's possible that they didn't build it into the motherboard because they didn't want to... they were concerned that a newer type of modem might come out, maybe. I don't know. I'm sure I saw more than one screw. Nope. Okay. Cool. I wish PC motherboards were this easy to remove. That's not bad going. Oh, there we go. There's the rest of it. It's got a heatsink on it, so after all of that, there's not a lot to see. However, there's the back of the board. So, of course, this is all mostly just pins for all of the things, but... Oh, there's some stuff going on. Is that onboard RAM? It must be. How about that? I didn't know that. These things have onboard RAM? That's all. That's the only thing that it could be. They must be RAM chips. Huh. I'm kind of glad I did this teardown. I'm learning things about an obsolete computer that I don't really care about and will probably never see again. But I don't know. If you're still watching this video, then probably you're finding this interesting as well. That's cool. Okay. As you can see, the dial-up modem just snakes across the bottom of the computer like that. Cool. All right, well, let's stick this back in. I think we've had our money's worth out there. Oh, look at that! Look at that ground connector. That's cool. It's got a big sort of spade connector that goes into a notch on the back of the chassis. That's quite funky. Because of course, otherwise they'd only have just sort of one screw terminal actually grounding this thing, because everything else is just these slots. And those slots don't have ground pads on them, so they're not using any of these cutout slots as ground points, which surprises me. You'd think that that's a logical thing to do, is just to have some exposed tin on the board for all of these to contact as extra grounding. But you know, okay. Let's get this guy back in. Oh, there we go. I was holding it too far out. Cool. Now I guess I just put that screw back in. You know, the G5 might have been drop dead gorgeous compared to these turn of the millennium looking things. You know, like this design with the see-through plastic and the you know, the bubble effects on it is just, it's so Y2K, it hurts. And you know, at the time when the G5 came along and it had all that, just, it was all solid machined aluminium, brushed aluminium, everything. It brought in, you know, the brushed aluminium era. You know, that was all very swish looking. But the design in these things is actually quite remarkable, to be honest. You know, all of the connectors, they've located all of these power connectors and stuff all down at the bottom of the board, so there's no trailing cables. And as you can see, the way that this whole computer just folds open is actually pretty cool. You know, I don't think I've given the G4 the credit it deserves. It's an interesting bit of engineering. As with a lot of Apple stuff, to be honest, you know, they may not, you know, I'm not going to pretend that Apple computers were the best, because they weren't really. They were, they had their uses, which is, you know, a subject of great debate, and you can argue till the cows came home as to what worked better for different people. But at the end of the day, you know, you can't deny that they were interesting. And as is the case with all art, you know, when it comes to art, did it make people talk about it? Did it evoke an emotion? And did it inspire conversation? Because if it did, then it did its job, you know. So from that perspective, these things were quite interesting. Okay, let's get this. Where was the... That goes on there. I think that went round that way round, maybe. Yeah, that went on like that, I believe. That just sits on there. And oh yeah, it does clear this. It does clear the components on the board. And then that went in like that. And just presses in. That's it. CPU fitted. I don't like the lack of locking connector, but then by the time you've got this big hunk of metal on top, that can't be aluminium. This must be steel. It's too heavy to be aluminium. But it can't. I can't imagine them making it out of anything other than aluminium. But it weighs a ton. Feels like it's made of copper, but it's not copper. Where was I? Yeah. It feels like it should have some kind of locking thing, but by the time you've got this heatsink on top, you know, it ain't gonna fall out, I can tell you that much. Right, let's get my bit of bog roll and just clean off the old thermal paste there. Groovy. Fine, let's stick some new thermal paste on our dual G4s. I'm using Arctic MX4 2019 edition, thank you very much. Put a little splodge on those. There we go. Now I need to figure out which way around this went. Yep, goes that way round because there's some cutouts for the huge inductors there. Just sit that on top. And we'll put the screws back in for that. And there's no spring mechanism on these screws. There's no retention bracket. But then the CPU board itself presses down into that socket. So I guess that is the hold down mechanism. You just screw these guys down to the stop and it's just pressing the card down into that surface connector. And then this little thing, that crosses over, I guess that's a grounding strip, which is going to be quite inconvenient to put back on from where I'm at now. That goes down, that goes that way around, I believe. I think I'm slightly out of focus, that's annoying. Okay. Right, let's remove that busted cap from the graphics card. So again, I haven't actually tried to power on this graphics card, but that cap is shorted to ground and is blown up. So I'm sure as heck not plugging it in. I've no idea what we'd replace it with. I'm just going to desolder it and leave it off the board. And, you know, the card will either work or it won't. And if it works, awesome. If it doesn't work, then it's dead anyway. However, you know, this thing is blown up. This graphics card is toast. So we may as well just take this thing off the board and just see if it works without it. Oh, I can smell the burnt electronics from that. Welded itself to the board. Can we remove that without destroying the pad? Oh boy, it's burnt a hole through the thing. I'm pulling bits of it off. I think that's the pad. Let's leave the pad on the board. Woo lad. Okay, I'm just going to cut that pad out. Right, let's just see if that's still shorted to ground. Ground check. Okay. So that's negative. Positive side. No, that's no longer shorted to ground. So we've removed the short circuit created by that busted cap. And so that also means, which side of this was ground then? Interesting, that's not grounded. Neither's that side. I wonder whether... So that trace comes up there and is stitched through the board. You can see the vias there where this track goes through the board. And it comes out there. And then this side comes up alongside it. So these two tracks go up through there, around to there, and they go to these pins here. So I wonder if that's isolated them. Are any of those grounded? They are not. And there'll be some ground pins in there somewhere, but... There we go. There's the ground pin. Interesting. Okay. Well, it's not shorted to ground. So this graphics card actually has a chance of working now. So yeah, it looks like that was a decoupling capacitor for the incoming voltage. So this card will probably work just fine without that capacitor for two reasons. Number one, if we don't use the Apple display connector, then we're not using that power rail anyway. And I don't think anyone is still using a proper classic Apple CRT or, you know, the Studio LCD. So I don't think that's going to be a big deal. And the other thing as well is that even if we were using the ADC connector for power, removing one decoupling capacitor, that's not going to cause a problem. It might put just ever so slight little bit of ripple on there, but most decoupling capacitors like this, or bypass capacitors, are mainly there to reduce electromagnetic interference. It reduces loop area of the power system to reduce any emissions generated by the computer. And so these emissions are only relevant for emissions, basically, because all electronics that you make, you have to, before you go to production, they have to pass emissions regulations for like FCC regulations and stuff like that to make sure that your electronic device doesn't broadcast X-rays and interfering radio waves and microwaves or whatever. And these bypass capacitors reduce the emissions from the device. So removing this doesn't mean it's going to start broadcasting a radio station, but it just means that it may have a little bit of extra noise coming off of it. But again, I don't think anyone's going to be using the ADC connector. This guy's almost certainly going to be running off of the DVI connector there. So cool, that guy's going to be fine, I think. Unless the GPU got blown up. Probably didn't. I think it'll be all right. As you can see, that power rail is actually quite independent. It's literally just an add-on for the Mac version of this card. Let's put it in. Cool. Well, what? Yeah, the hard drive in there is a 120 gig, so it's got its original hard drive. I should probably test that, but I think what we're going to do now is we're going to power this thing on and see if it actually works. I think that's what we're going to do. Yeah, that's cool. Let's close that up. Boff. Okay, I'm going to be a VGA scrub for this because I can't find or have sold my DVI to HDMI adapters, which means I can't connect into my display capture system. But I might actually make an extra special effort just for you guys to find it if this thing actually powers up and works. It depends if there's anything interesting to see in the software side of things. And I don't know if there will be anything yet. Let's see if this thing powers on first though. Right, powering. Mouse and keyboard. Okay, let's see what we get. Power. Oh, it's noisy. It chimed. Input VGA. Oh, we have got display. we go. Right, let me just show you guys what I'm seeing. Oh, we got macOS 9.2. How about that? Oh, that's exciting. System 9.2, thank you very much. God, I sound like Dave Jones in this video. I've been watching EV blog lately, so I've been picking up all of his catchphrases. Always looks strange when you see really old computers on really new monitors. Look at it. This is macOS System 9.2. Can we get a year on this thing? But it's got a high-res background on it, and it's running on a 1920 by 1200 monitor. And it's actually got the ability to drive that. That's brilliant about this computer. Right. Copyright Apple computer to 2001. So yeah. Built-in memory 256. Largest unused. So built-in memory 256. What does that mean? Does that mean total RAM is 256? I'm not sure. Can we get more system information just to confirm? Control panels? I'm really bad at System 9. I don't know System 9 at all. It was before my time, basically. Memory. Let's have a look in memory. Oh, that's RAM disks and stuff like that. Nah, you're alright, mate. Yeah, the fact that it's saying available built-in memory, that sounds like that's the amount of RAM to me. So I'm going with that. Anything else interesting here? Multiple users, wow. No, that's fine. What have we got in display? Monitor? Monitors. Yeah, we're driving at 1600 by 1200. Can we have? We can. 1920 by 1200. Give me that. Oh, beautiful. With millions of colours. Cool. And it even reads the name of the monitor. It's a Dell U2412. That's fantastic. That's really cool. Okay. Well, that's about... okay, well that concludes my interest in this particular install of macOS. I have a system image for another G4 that I'm going to be writing to this one, which has the customer's data on it. So although this is kind of interesting, I'm not actually going to do anything there. No way, it's got a color sync profile. How does it do that? Is that built into the monitor? That's amazing. Well, I'm sure other computers can do this. It's just, I'm often surprised by when you plug new equipment into old computers when they can just handle it, you know. When they, you know, I just, yeah. All right. That's all. OS 10. It does have macOS 10 on it. What version of macOS 10 does it have? Control panel, startup disk. OS 10, restart. It's got 10.4 on it. That sounds about right. Let's have a look at that. Yeah, there's a macOS 10 startup screen. I'm going to put this thing on the floor while it thinks about that. It's a noisy beast, and I don't know if I can do anything about that. Your computer's clock is wrong. Yeah, that doesn't surprise me. Can't identify your keyboard. My monitor is wonky. That's going to be fixable, but we're on analog input, so we're going to see these kinds of issues. But yeah. Yeah, macOS 10.4, yeah, 256 megs. So it looks like it doesn't have onboard memory. I wonder what those chips along the back were then. I wish I'd looked those up. I think I will do that in post. Very cool. Right, let's shut that down. Take a look at the other one. Oh, that fan in it is dreadfully noisy. We'll see if we can apply any kind of power to this other one that I have. And see if we can find out how noisy that fan is at the back. I don't know if it's worth swapping them out though, that's the problem. See, the other thing to consider is that we just simply move all of the stuff in that computer over to this one, because the motherboards look basically identical, except this one's a year newer. So I'm kind of thinking of just swapping all the hardware out. But this one had a smaller power supply in it, and I don't want to lose the 400 watt power supply, and I ain't swapping that out because that's a pain in the ass. So some interesting differences here. It's still got the two-phase CPU V core going on there, although it's a slightly different layout. Still got the same kind of, mass decoupling on it. And on the back, we've still got the two low-side MOSFETs, similar looking controller setup, and again, the two phases are common together at the outputs. However, they're common together just in a different way, but again, the same design principles there. Then we've got our single CPU in the middle there. Some extra power going on up there, and on the back of it we've got again the two 1 megabyte level 3 caches, and those are just both mounted on the back of the board. So yeah, interesting, same kind of deal, different layout, but yeah, as you can see, Apple can just plonk a different board into this depending on the configuration of it. The actual motherboard, to all intent and purpose, looks identical to me. I can't see any significant differences there. There might be one or two components that are just slightly out of place, but I can't see anything relevant there. So yeah, that's kind of fascinating. Cool. Okay. Right, I'm gonna try powering this one up with no RAM in it, just to hear how noisy the fans in it are. So I need to disconnect the speaker to do that. Which, incidentally, is this guy on the 3-pin connector down there. Interesting. Fine, that's cool. Anything else? Yeah, we'll put the CPU cooler back on. I'm not going to bother changing the thermal paste on this one. It's this one isn't going to get used, so I don't particularly care. Oh yeah, this fan here, that's another one that might be causing the noise. That's providing cooling to the optical drives for some strange reason. Not sure that's entirely necessary. That's probably where most of the noise comes from, actually, come to think of it. We'll do some experiments in a minute. Okay, let's get this one powered up and see how much noise it makes. This is going to be awkward. I've got to put it there so I've got room to open the box up. There's no way of giving you a good view of this. Okay, I'm just going to power this on. Here we go, let's go. It's not doing anything. Is there anything critical it's missing? Power button comes in over there. Oh, you know what? I think that might have been the power button. No, it's not. The power button is the flex under that ribbon cable there. That was definitely plugged in. This one looks like it's dead, Jim. Unless it won't do anything with no RAM connected. No. This one's dead. Okay then. Well, that's why that one's thrown out then. Okay, well, I'm not going to spend any time on that. I don't think the client cares about that. We've got one that is fully working and one that is stone dead. So taking the RAM. Is there anything else I'm going to want from that? I don't think so. Because this one is dead, that's suddenly become incredibly less attractive. So, I think we're going to focus on the one that works. So the only other things to note, that's the power supply back there. And then we've got the hard drive there. And you can mount 2 hard drives in there. It's got a dual connection IDE ribbon there, or parallel ATA ribbon. So you can put 2 hard drives in it. Some of the other versions, there's one of the screws that was rattling around. Some of the other versions had the hard drives mounted on the bottom, but there's a slightly different layout. As I said, I've got one round the back. And you know what? Because we're just doing a weird, G4 discovery video, let me get my old one out and let's just see what's in that, just for funsies. But yeah, that's it. Hard drive, power supply, optical drive. You can have 2 optical drives in there as well. And then there's a speaker there. That white box is a speaker. And this is the front panel here. That's got the power button behind it and the headphone jack. Cool. Let's rearrange. Cool. Right, so here's my G4. It's incredibly dusty. So as you can see, this one doesn't have the mirror front drawers. Still got a floppy disk drive in it. It has got a DVD drive back there. It's a DVD-ROM. So yeah, I don't know if this one runs. I guess I could turn it on. I don't know if I want to. However, I thought I'd get it out just to show you as a comparison for the internals. There we go. Here's the classic layout on the inside. So as you can see, the power supply is still up here. And then we've got this main big flat fan here that just kind of blows onto everything inside. And I'll show you this in a bit more detail in a sec. Optical drive is still there with a floppy drive under it. And same basic principle of the power drive's coming out. And the hard drive is down here. So there's our hard drive down the bottom there. And then, in fact, it's literally the other way up. I've just noticed that. So yeah, we've got, again, Pci-X slots down here. There's our PRAM battery. There's our modem. And there's the graphics card, which is an AGP. However, this one doesn't have the ADP connector on it. It doesn't have the ADP spade. And it's a VGA and DVI monitor. And DVI output. We've inexplicably got an internal Firewire header there. Not sure what that's for. And then, of course, our CPU is over here. And once again, the CPU is mounted on a card connector. So can I remove that? I've got to remove the cooler. You know what? We've come this far. Let's do it. How do I remove cooler? Some pliers. I didn't need to move. Nope. Didn't need to remove that. Just needed to get good. Okay. Ooh. I've no idea what this one is. It's probably an 800 megahertz or something like that. Much smaller die on this one. It looks like a completely different chip. It's still a G4, just looks completely different. I think this one probably lacks the Velocity engine. It's probably a much earlier G4. It's got a single CPU phase on it, which is on the... Oh, that's interesting. The inductor is over there, but... oh yeah, so that we had some of those power FETs over there. So it might be handling them through these guys here. And we've got another couple of guys on the back, so they might be using smaller FETs there. I'm not sure what this guy is up to. We saw these on the other ones, but without looking up the chip, I'm not 100% certain there. Less decoupling overall, but still, well, yeah, not a huge amount of bypass caps on this one. So, yeah, that one looks surprisingly empty. We've got this guy here. I'm not sure what this guy is all about. It could be a cache chip. SEC Korea. What do you reckon? Early Samsung, maybe? Could be. Let's look that one up, since it's the only chip. We haven't done any chip lookups at all. I'm going to Google that one. Yes, it is a level 3 cache. So yeah, that's an external level 3 cache. It just looks slightly less fancy than the ones we saw on the newer ones. So not entirely surprising. That's yeah, it's there. It's external. That's what they did with these ones. Internal level 1 and level 2 cache, level 3 cache, external. Again, it's from the era where I think the level 3 caches had just been added to computers. Oh yeah, we've got another one on the bottom there. So same deal. So yeah, I think it was just the fashion of the time to have them external. And I think the next generation of CPUs, they mounted it internally inside the chip. Cool. Well, that's that. And I think that's about all I've got time for today. So yeah, that wasn't really the repair video that I was expecting it to be, but instead I just sort of took a bit of a mad tumble through the world of the Apple Power Mac G4. This wasn't really a super concise teardown or anything like that, but I hope you guys found it kind of interesting. I'm sure there's going to be people out there who know an awful lot more about these than I do. That tends to happen when I do teardowns. But, I don't profess to be an expert on these. But yeah, I hope that that you guys found some of it kind of interesting. It's just an opportunity to take a slightly closer look at something that you otherwise may not have taken an interest in. Let's see if I can get this CPU cooler back on before I close up. Okay, that's got 2 pins on the bottom of it. There we go. I did it. And then that guy just clips on. Ah, damn it. It's only clipped on one side. Here's some more bonus footage here. I just suddenly looked on the wall behind me and was like, oh, I've got an iMac G4 board here. So yes, this is the round logic board from an iMac G4. It's the one that everyone always says, where's that one from, when they're looking at my wall. Anyway, so this one I thought was kind of interesting because it's different but also the same. It's got a very, very similar rationale behind it as the Power Macs that we were looking at. This one again is an older one. This is a G4 800 megahertz with with SD RAM on it. So it's like the older G4 that we looked at, not the mirror doors. And it's got the same kind of thing. We've got our PRAM battery here. There's our PRAM chip over there. This one has got some extras on it because we've got onboard graphics. We've got a GeForce 2 MX card there. And then we've got a couple of memory chips for the graphics card. Then down here, we've got our single-phase CPU V-core, big inductor, lots of bypass capacitors. Then we've got our, again, Motorola G4 CPU. But the interesting thing is that this one doesn't have the level 3 cache on it. It's got space where a level 3 cache chip could go on both sides of the board. But the actual level 3 cache chips itself is missing. And that tallies with the spec of this board when you look it up, is that the iMac didn't have the level 3 cache. Right, and double bonus, here is my eMac 5000 sub special video, and I didn't look into this at the time when I was tearing this down, but again, if you have a look here, we've got G4 CPU, and again, it lacks the level 3 cache. This one was a 1 gigahertz one, but because the eMac was a more budget system, they obviously, again, they omitted that level 3 cache. So that's kind of interesting, really. It's interesting to see where they cut corners and where they didn't. You can see where they reduced the cost of the build and where they put on the extra performance for the actual workstation class machines. Well, this video ended up being a lot less sort of focused than I expected it to be. But you know what? I'm kind of glad that I made it, really, because I've always kind of turned up my nose at the Power Mac G4 because it was just before my time, basically. I've been working on computers since the mid-90s, but obviously you don't really get a broad scope for the world of computers until you do it at a professional level. And by the time I went professional with IT, this thing was already gone and the G5 was out and about. However, comparing this to the G5, obviously the G5 is a superior computer in terms of performance and modern technology. However, by comparison, this thing is really easy to disassemble and change parts on and stuff like that. The G5 is a nightmare to work with. As soon as you're not doing something really basic in a G5, like changing a hard drive or even the memory is complicated in the G5 because it takes ECC RAM and it has to be in certain orders and stuff like that. Whereas this is it's so easy to work with this thing. It was a really well-built machine. It's got all of this steel, you know, all this steel girders and stuff like that. It's not as attractive or elegant as the G5 is, and it's bloody loud, but it's got a certain thing to it, a certain thing where the designers of this wanted to make something accessible and serviceable and just something that people could work with. And I kind of feel like that harkens back to the days of Apple before something all went horribly wrong. You know, because something has gone horribly wrong with Apple, really, hasn't it? And this kind of just highlights how much of a problem that really is when you look at how easy this is to work with and disassemble compared to a modern Mac. Oh well. Thanks for watching, everyone. I'll see you all next time. Bye for now.